That's when I said it started. Better than your math?
Yeah. I think my math's only a 30. Yeah. Yeah, geometry. Yeah, I forgot everything. So, you check in.
You said you could start on iteration on the back.
Okay.
I'm just going to start. All right. I am going to record. Oh, I am recording already. Wow. I guess I had a couple minutes of dead time. All right. So we're going to just go look at contextual applications of derivatives. Basically 7 sections in less than 10 minutes because you were pretty good at this stuff. And then the main thing I want for the review is the backside. But just really make sure you understand what a derivative is and what it tells you. So when it says the function c of x is the cost of digging a hole x feet deep, then the x is the feet and the output is the cost. So that means a hole that is 20 feet deep costs $140 to dig. That's easy, correct? But that's not calculus. The calculus is knowing if c prime of 20 equals 5. I want you to fill in those blanks. Contextual derivatives. We're not going to do the particle motion part because we discussed that explicitly already, but c prime of 20 equals 5 means that, all right, fill in the first blank, means that when the hole is 20 feet deep, okay, that's actually the t, that's the time, right? The cost of digging is, what's it doing? Increasing. What word could you use for full credit? Changing. Which one's probably safer? Changing, but I like increasing better. Awesome. At a rate of, thank you for the units, 5 feet per dollar. Yeah. Or dollar per foot. Sorry. All right. Yes, changing y over changing x, and y is the money. All right, that's it for that one. 4.2, a particle moves back and forth along a horizontal track. It's going like this. And s of t is given in feet. That's the position, that's where it is. Find the acceleration. What would you do? How many times? And what's the derivative of tangent? Secant squared. And how would you do the derivative of secant squared? Secant squared. Then we need to talk about that one. All right, so on your second derivative, so your first derivative would be 1/2 secant squared t. That's your velocity. Your acceleration would be 1/2. That's a function inside of a function. What do you use? What was sine squared? Chain rule. Yes. So 2 times, and I chose this one for a reason because it has the 2 you're supposed to memorize that people forget. So it's 2 times what? Secant t to the first. Just like if it was sine squared x, you'd say 2 sine x times the derivative of the guts, correct? So this is 2 secant t to the first, technically. But if that was a 3, it'd go to a 2. If that was a 4, it'd go to a 3. Times the derivative of secant. What's its derivative? Secant tangent. So I chose that one for the memorization of it. Do you get that? Why I chose it? And then you'd have to do that at pi over 6. So a little unit circle in there as well. What is secant? 1 over what? The pre-calc. Secant is 1 over cosine. Yeah. At pi 6, Again, if this was multiple choice, you need to know these, right? Pi sixths is this guy right here. It has a half in the back end and a what in the front end? What? 3. Again, I don't do stuff. I think that's over 3 over 2. You see it?
Yeah.
All right. So it'd be 1 over the cosine. That's how you get the secant. You need to actually flip. Maybe 2 over 3. Don't rationalize the denominator. All right. I'm not going to finish it. All right. Again, these just all have a little funk to them. I'm going to tell you the most common wrong answer. P of t models the size of a population. Which of the following differential equations describes a linear growth of the population? Most people go linear. It's this one. Careful. The derivative ended up being of a linear. It was a linear. It's increasing at like 400x plus 9, right? A linear model, what's its derivative? A constant. What should it be? I put this one on here because this one was on a BC one, and half of them chose. They don't read the full problem. They go, They go like this, and what word do they see? Linear, right? The population, though, originally, so hadn't been linear, so we would have this guy. What scale is the number 4.4? What is that when it says determine this is a what? Related rate in an abstract way. Who cares? We need to take the derivative of both sides with respect to what variable? T. So we need to do dz dt equals the derivative with respect to t of these. Boom. I'm trying to find dz dt, so the left is done. What rule do I launch into on the right? Product, right? And chain. Excellent. So let's go do that. It equals first derivative of the second. What's the derivative of the second? 2y times dy dt. Exactly. You might even want to write, well, I need to do the derivative of the second. You go, okay, it's 2y, but times the derivative of the guts would be dy dt. So just make sure that chain rules back. So that's first d second plus second d first. If it was dx dx, I'd write 1, but it's not. It's dx what? dt. And then you just go plug numbers in, and I'm not going to plug numbers in because I don't want to, and I want to be done, like I said, fairly early. We already did a free response on particle motion, so that's out. Read 4.6 and tell me what it's testing. What is that skill? Tangent line. Approximation. Yeah. So you need the tangent line first. Go get it. See if you remember how to get a tangent line. About which little else is known other than g of negative 3 equals 2 and g prime and negative 3 equals 7. What's your point? Not like, what's your point, but what's the point? Negative 3 comma 2. What's the slope there? 7. That's not calculus, that's algebra, right? Y minus the y, you know. So y minus 2 equals 7 times x plus 3. Don't move on. If it asks for the equation of the tangent line, you're done. But this says to approximate it at negative 2.9. So what do we do at negative 2.9? Plug it in and get your answer. I'm going to put a little addendum to that question that comes with that one a lot if it's an FRQ. Is this an over or underestimate? What else would you need to know to decide if your tangent line at a particular spot was it, tangent line at a particular place was an over or an underestimate? I'm happy as afraid you'd say increasing or decreasing. That's for the Riemann sums. Right as an increasing. If they told you and g double prime of negative 3 is less than 0, then you go, oh, I'm concave down in that area. So I have a over S. right? Because I'm on the line with my approximation. And Gunnar knows that these tangent line approximations are pretty crappy, and we get really good ones in BC. We have something called Euler's method, and then we have his favorite, Taylor series. Which actually are how your calculator's programmed, so they're really historically great. Next up, a limit. What do we do when we calculate a limit? You better get so sick of my voice in your head. Plug it in. What do we usually get?
0, 0.
But we plug it in anyway, just in case we don't. So 5 to the 4th is 625, and 5 squared is 25. Now what do? We have two options for this one. You can Lapados. Seriously, Rion. All right. It's his name, Rion Weingerd. So you could L'Hopital. You could say I'm going to do 4x cubed, and then the derivative is gone, over 2x. And then do what? Plug it in again. I'm going to go do that. Oh, 5 cubed, 125. What is it?
500 over 10.
Okay, whatever. 500 over 10? 50. But perhaps you don't want to do it that way. Do you see another way you could do it? You could factor, and that's a difference of squares. You don't only do that when they're polynomials, but sometimes there's, but L'Hopital do it. You cancel out the issue, hello, removable discontinuity, right? Plug the 5 in, and guess what you get? All right. Next is what's on the back page, which is mainly why I called these here, but I thought there's some funk on the first page. We're going to discuss it, but I have to write them down while I go because for my distance learners, they're allowed to do these and send it to me. On the back, distance learners, if you're watching this, our first integral is this one. Your first question is, what should you do first? Before you even start, bring a 5 over. You don't have to. So if you hadn't said that, I'd be okay with it. Then you're going to decide on your technique. Is it a heart? Can I break it apart? Can I just mess with the integrand? Is it u sub? Maybe. Who's u? Inside function, there isn't one. Or the denominator, there is one. Let's try it. Right? So we're going to do 5. I just want to talk you through some u sub, and that process has to stick in your head. Those are juniors, once you get to BC, you'll have done all them so often. You'll just look at it and go, that's u sub. Did you guys not look at them today, even though we're doing improper integrals? They're like, oh, u sub, biparts, arctan. Like, you'll have done it so much, but it's still not quite where you've done it. You know what I mean? You haven't used it. They use it all the time. So is this u sub or not? Well, my only hope, I'm not going to say yes until I take the derivative and hopefully generate the rest of the integrand, which I almost did. I've got the stupid 2 in the way. If you can get rid of it with a number, you do it. Now, you can't just wipe out variables or functions, but I can wipe out that 2 by just going, you know what, x dx, I'm going to place you with 1/2 du. Now you're going to go over here and say, well, what did I have here? I have 5. I have the integral. My u choice is on the bottom. The whole rest of that is 1/2, but constants come out front, du. That was u sub, with the intent and hope of passing the buck to who? Natural log, right? Because it's now u prime over u. So it'd be 5/2 natural log, technically absolute value, but they're not needed, but put them there anyway. Why do I say that? You got a 35. Say, why don't I need to put the absolute value on this one? 5/2 natural log, absolute value x squared plus 3, plus my good friend Carl is correct. But technically, if I left them off, we couldn't take a point after forgetting the absolute value. Because of why, Jake?
Oh, I didn't understand. Because it's squared. So
Yeah. So x squared is positive for all real x. If it was like this, though, they are necessary. So don't even go there, just put them on all the time. All right, next one up, let's look at it. Most common wrong answer, natural log, x to the 4th plus c. Very careful. That is not u prime over u. What will you use on number 2? Oh, I'm going to write it so that the distance learners can see it. You don't need to do it. I'm just going to say there's always a multiple choice one like that. And kids go, oh, that's easy. Natural log s to the 4th. And they move on. That's not natural log. What do you use? Power rule. That's x to the negative 4th. You add 1 to the power. Divide by that power. And it's so easy now. Right? But you're going to see that natural log in your gut instinct with that denominator is going to go there. Now, let's do the next one. Number 3 is kind of a mess. It's a secant squared. I want you guys to write down who you think u is. Who you think u is? Write that down. The inside function, I'm going to go 3x. Well, good luck getting secant squared or 3x. Right? I'm going to let it be. Oh, super. I'm going to let it be tangent 3x, and if that doesn't work, I better try secant, and if that doesn't work, I don't know what I'm doing, or it can't be done. There's only a finite number of things to try. So if this is my u choice, I'll go take my du, tell me what's wrong with it right now.
Let's go 3 up.
Right. Well, I do have a multiple of the rest of the integrand. I can replace secant squared 3x with, not du, but 1/3 of it. So if you have to take the time to write that down, do it. Do some of it in your head if you can, but if you know you can't, go ahead and write that. And say, I'm going to bring the 1/3 out front. I have u du. Hello, that's easy. What's the antiderivative of u? U squared over 2, but don't quit. Plus c, but don't quit. Problem wasn't about you. Throw back in. And there we go. All right, let's look at the next one on there. Ask yourself on number 4, u sub or not. I'm going to write it for the distance learners, but I want you guys to start. U sub or not, if so, who's u? If not, do it the other way, that you think it might be able to be done. And I'm not going to do the whole one. This is just u sub or not. And where do I go from there? Distance learners, it looks like that. I look at that and I go, icky puke in my mouth. And I have to start. I'm going to go to u sub. Who's u? Inside function I try first. 5 minus 2x squared. Let's go see if it works. That would now be the cubed root of u, and now I've got all those x's in there that have to go to u as well. Can't mix variables. So who's du? Negative 4x dx. What should I have done with the 7 so it doesn't mess with my head? Bring it out front before I even start, so I'm not thinking, I need to replace 7x dx. No, you don't. You need to replace x dx. Bless you. With a what? Negative 1/4. I already had the 7. So negative 1/4, the integral of the cubed root of u and the whole rest of it. How do I integrate 1 over the cubed root of u? U to the negative 1/3 needs to get integrated. What do I do to it? Add 1, divide by. Do I need to go on with that one? I think we're good. You're shaking your head no. I love number 5. I just want you guys to, I got to write it down for distance. Number 5 was this. Run through all your stuff, and then I might ask Gunnar what this one goes to. Get that 9 out of there first. Number 5, if he had that today on a different type, it's called an improper integral. And he is sitting there going, how do I integrate that? And I don't want to put you on the spot if you don't remember, but I'll say it.
I think I kind of
Okay.
remember.
So let's get that 9 out of there first. And it seems like everything fails. I think I'm like, I can't do it. You can. Because I've taught you all the techniques except one. The one with long division. That's on Mondays. This is arctip. Yes. I'm sorry, I forgot to ask Gunnar. I would go like that, just go 9, 1 over a squared plus u squared. Oh, now I need to take my memory. What is it? 1 over analysis, arctan, urine analysis. So it's going to be 9 times 1 over 2 arctan x over 2 plus my good friend Carl the constant. What if it was like this and like that? Arc sine, but no 1 over 8. Just arc sine urine analysis. All right, we've got 2 more, I think. Number 6, you guys just tell me u sub or not. U sub or not? What if Bryce says, it makes a heart, LaRue, break it apart and say, Bryce, my friend, it makes an upside down. Right? But if it was the other way, I would do that. I'd call it 1 plus, it is flipped over, right? But it's not. Who's you? Who's your only choice? The denominator. E to the x plus 3 would be my u. You can almost do this one in your head. Du is exactly the rest of it. This is 1 over u du, y'all. This is a natural law. Absolute value. U choice. Plus Carl the constant. How are we doing? Okay. Distance learners, they're all nodding and I'm feeling good about it. So I'm going to go to number 7. There's only 8. And we started, I said I wanted to be done. I'm almost done. Be about 5 minutes longer. What would I do if you say write 6 minus x 8 times and FOIL and distribute and distribute and distribute and distribute and distribute and distribute and then combine like terms and then anti-derivate every term, you will get the right answer. Right? But 3 out front. Who's you? 6 minus x. Does it need a fraction correction? What? A -1. Exactly. This is u to the 8th. If my u is 6 minus x, my du is negative dx. So let's do a little negative, right? That's in the integrand. What's the antiderivative? U to the 9 over 9 plus Carl. Then do what? Shove 6 minus x back in. And you'll get the cleaned up version of it. You had been unwise and actually tried to multiply that all a zillion times. But if this was a 2, I don't know, maybe you want to FOIL it and just do each term individually. But if that was a 23, don't do it. All right, last one. I want to see if you get this one. I think you're going to make a mistake. It's very common because you're going to try to do it in your head and you're going to neglect something. It happens in BC quite a bit with this kind. You might know what I'm talking about, hopefully. Okay. So when I look at that, I go, I'm stuck. No, I'm not. LaRue taught us how to do it. I just don't remember. What else could I do? Looking a little squarey down there. Looking a little ugly. Looking a little woody. Arcsine. Go see if you can do that one correct. I'm worried about something. Do it without doing it in your head, and you're going to probably fix something that you didn't. Very, 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 very careful. If it was just an x there, x squared, I mean, I'd do it in my head. But that 25, careful. I'd identify your A. I'd identify your U out there. Alright? It happens all the time. Luckily, that's usually an x squared. But we don't review the stuff that's usual at this point when the test is 3 days away. We review the weird stuff. So who's your A? 3. Who's your U? 5x. Who's your DU? 5dx. What's dx? That's what I'm afraid of. That guy. When it's just an x, du is dx, so you're fine. But when you do your arc sine, u over a plus c, you got to be a little careful because that's 1 over a squared minus u squared dx. dx is a fifth du, not just du. So what should be in front of mine? 1/5. That scares me, but it probably won't happen. We're done! Take a picture, distance learners, if you did it, and put it on the Google Turn-In. Same with you guys here. Some of you who were here last time, I don't think you sent me a picture, some of you. Like Schuster, I don't know that I got yours. And I know it's easy for me just to collect them, but it's actually not when there's so many random pieces with random people doing random pieces. So take a picture, submit it, head on out. Distance learners, if you did it, again, just submit it on our Google Doc.